Uh, yeah, I'm gonna, maybe. Brianna, you be the judge. Do we need to turn, oh, good grief.
When it turns on, I'll let you know.
Okay. So what I was gonna say is, did I hit record? La 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 la. Is the red thing on? So, larger point in here is if you didn't do what you'd hoped to on this test, it's not, all is not lost. You can still replace this test grade with the final exam part 1 grade, and it will erase the evidence of whatever happened. All right. So, but it's important to figure out what happened, right? So can we see this?
It's at least one line.
All right, so let's talk about problem 1. We're supposed to solve minus 5/3 x plus 4 equals to 7/3. So what I did was to multiply by 3 and distribute the 3. So 3 times 5/3 is minus 5. 3 times 4 is 12. And then I subtracted 12 from both sides. That isolated minus 5x and got me minus 5x is equal to minus 5. Then I divided by minus 5, and I got x equals to 1. A lot of people got this right. I would say half the class at least got this right, maybe. For the people who got it wrong, what happened? More often than not, I think you made a sign error moving one thing from one side to another. In fact, if I had to make any general observation about what went wrong algebraically for most of you guys, it's like you're careless about when you move things from the left-hand side to the right-hand side, needing to change from plus to minus, right? So like I think that's the major, and also just arithmetic mistakes, like stuff like, minus 4, minus 6 being minus 2 or something rather than minus 10. Like adding negative quantities, and that's another major source of errors. But anyway, like I was just saying, you can come to me in office hours. We can look at your particular test, and I can try to tell you why what you did wasn't quite right. Assuming I can read your handwriting, which is not the case for everyone. I don't remember who it was, but my goodness, you guys are really giving me some of you guys are really giving me a headache. It is so light. Others of you, that your handwriting is beautiful. But anyway, this next one, 7x plus 18 equals to 3x minus 26. So I subtract 3x from both sides, and I subtract 18 from both sides. I get that, right? And so 7 minus 3 is 4, minus 26 minus 18 is minus 44. A lot of you made an arithmetic mistake right here, and that's why you got that problem wrong. Like you didn't get minus 44 here, you got like 8 or something like that, or minus 8. That was a pretty common mistake. Anyway, the answer is minus 11. If you have any questions, just jump in while I'm talking, okay? Next up here, problem 3. I decided to divide both sides by 4 to make my life easier. So I divide by 4, I get 8x over 4 equals to x minus 6. But, of course, 8 over 4 is 2. So that gives me x minus 6 is 2x. And then I isolate the x's by subtracting x to the other side. So minus 6 is equal to 2x minus x, which gives me minus 6 is equal to x. In other words, x equals to minus 6. I don't remember what people did wrong here, but certainly many of you got it right. So let's go on. Okay, here, problem 4. I tried to warn you on the quiz that this was like a problem that you need to know how to solve, right? And I tried to warn you, and we talked about the quiz, that, hey, there are 2 answers to this kind of problem, right? But still, at least a third of you are just giving me 1 answer to this absolute value question. But there are 2 answers. We have to think about the plus and the minus. And the minus, ends up giving me the 17 thirds, but the plus ends up giving me -1. So many more of you had the -1 solution than had the 17 thirds solution. So there you go. Just point of order going forward. Remember, when we're solving absolute value equation, we're probably going to get 2 solutions, not just 1, right? Are these lines parallel? Now, yes. Yes, they are. Are they perpendicular? No, they're not perpendicular. To judge whether or not 2 given pairs of lines are parallel or perpendicular, I would suggest solving both for y equals mx plus b, and then you can compare them. If they have the same slope, they're parallel. If they have negative reciprocal slopes, they're perpendicular, and otherwise, they're just nothing. They're skew. Perpendicular lines are also skew. That's true. Anytime the 2 lines don't have the same slope, they're said to be skew lines. So like perpendicular is a special case of skew, technically. I saw the most interesting wrong answer here I saw was, I had one person tell me that one line was parallel and the other line was perpendicular. This is very wrong. Parallel and perpendicular, these are when we compare 2 lines. So like, it's a trait shared by a pair of lines. Either they're parallel or they're perpendicular, or they're neither. But anyway, problem 5. Problem 6. Hey, I think a lot of you. So for problem 6, I made a critical mistake, and my critical mistake is one I've made before. I tried to be nice and make the numbers easy, but my reward for that was there's about a fourth of you in here who are bright enough that you can just look at these numbers and go, by reasoning, by figuring, I figured out the answer is 200 and 300. And so I had to give you credit because I didn't say use algebra. I didn't force the issue of how you solve this problem. I wanted you to solve it with algebra. So some of you got full credit for here just for being clever and figuring out the answer by just pure reasoning, like I would have when I was, a 12-year-old or whatever. And I'm happy. That's what I always am happy students are thinking, right? But we do want to solve this algebraically. Because if I make the numbers uglier, then you'll have to do algebra, right? But here it is. So length is w plus 100. So the perimeter is w plus w plus w plus 100 plus w plus 100, which ends up being 4w plus 200. And then when we subtract 200 to the other side, we end up with 800 is 4 times the width, which gives us that the width is 200. And of course, the length is 100 more, which is 300. And then finally, the area is 200 times 300, which is 60,000 square feet. A lot of you forgot to do the area. I took off 5 points if you did that. It's an unfortunate oversight, but there it is. Inequalities. Most people need to work harder on inequalities. There's a lot of people who are not where they need to be on inequalities yet. And I understand, inequalities are harder. I get it, But we just have to follow a few simple rules, like we can add and subtract numbers from inequalities. We can divide by a positive number. It doesn't change the inequality, right? But when we divide by a negative number, we need to make sure we flip the inequality, right? Less than becomes greater than and vice versa. So for this one moment, let me get my laser. All right. So I guess this one, there we go. So All right, so I start by doing what? I subtract 5 over here, right? And I add 2x to the other side. So just add 2x to both sides, subtract 5 from both sides. That gets me to here, right? 3 minus 5 is minus 2, right? So minus 2 is greater than 2x. Now, I divided by 2. That gives me minus 1 is greater than x. Personally, I don't like to think of it that way. I like to put the x first. So I have x less than minus 1. What is x less than minus 1? In an interval notation, that goes from minus infinity all the way up to minus 1 not included. All right? So, you know, a lot of people got this right. And I have a suspicion that many of the people sitting here got it right. Now this one here, there were some problems. It's hard for me to even to summarize the exact way people got this wrong. It was just wrong. But anyway, here's the story. So if we have absolute value larger than or equal to something, there are two cases, right? The one case is that the thing inside the absolute value is less than minus that number. The other thing is that the thing inside the absolute value is greater than that number. These are the two different separate cases we have to solve. And so that gives me 2x is less than minus 12, which tells me x is less than minus 6. On the flip side, we have 2x is less than 4 minus 8, which is minus 4. Dividing by 2 gives me x greater than or equal to minus 2. X greater than or equal to minus 2 is this interval. X less than or equal to minus 6 is that interval. I take the union, and that gives me the answer. A lot of you need to work on this problem before, you know, it reappears in the final, if it does, you know. Now, this problem right here is a close cousin, isn't it? This is the same exact expression, except instead of having greater than or equal to 4, I have less than 4, right? So if you think about this logically, the answer should be the complement of the other one, in the sense that it should be everything that wasn't in the previous answer. And if you look at the previous answer, these are all the real numbers that were not in the previous answer. Like the previous answer goes from minus infinity to 6 included, and then unioned with minus 2 to infinity included. These are all the numbers which are not in the previous answer. So there's that. Did I say that right?
Why do this problem different?
Oh, they're different problems.
I mean, why do you have to have two separate equations for the one
Yeah, that's what I
above
don't
it, but the one below it that's almost the same, you don't have to have two separate equations?
Because the less than and greater than problem for absolute value, they're fundamentally different problems.
I thought you said if there was like multiple, then you have two problems for them.
If they what? Say again? I said if they're what?
But when I have two lines in
Mm-hmm.
the equation, so do the like on number 8, how you did 2,
Mm-hmm.
like I did.
You could do it that way for the I forgot the number. It's true. You could break both of these into two cases. All right? But you don't need to for problem 9 because the same x satisfies both of the inequalities. Let me just, all right. Let's look at something a little bit simpler. So let's just say, you know, absolute value of x greater than 4. Right? So absolute value of x greater than 4 either means minus x is greater than 4, or it means that x is greater than 4, right? But case number 1 is really what? X is less than minus 4, right? So if you drew both of those on the number line, right? If this is 0, if I call this case, case 1 and case 2, can we have both of those at the same time? I mean, no, those are distinct cases, right? You're either beyond 4 over here, right? Like this is your x, right? Or you're what? Less than 4 over here, right? And so that's one possibility. Solving that, I mean, so in other words, what I'm trying to say is the answer here is the union of these two, right? It's minus infinity to minus 4 unioned with 4 to infinity. In contrast, if I have, absolute value of x less than 4, right? And I think about that same breakdown. So I either have minus x less than 4, right? Or I have x less than 4, those two cases. And those cases are the negative and the positive case for x, right? What does that top equation tell you? We can rewrite this as what? X greater than minus 4, right? And the thing is, these two inequalities play nice together. The same x can satisfy both of these. Right? So, let's see here. So I'm trying to say is we can write minus 4 is less than x is less than 4. And so like the picture, in this case, here's 0, and here's 4, and here's minus 4, and it's simply that whole, the solution here is minus 4 to 4. There is an asymmetry. What I'm trying to say is there is a distinction in less than or greater than how you treat these inequality problems. They're not treated the same way. If we look at them just from, like I don't always, I only did this like once in here maybe. Every time after, whenever I come to something like, if I'm going to solve 3x plus 17 less than 2, I will immediately take this and change it to minus 2 less than 3x plus 17 less than 2 and deal with that. In contrast, if I'm solving 3x plus 17 greater than 2, that gives me two distinct cases. It gives me 3x plus 17 less than minus 2, or 3x plus 17 greater than 2.
So only when it's less than you put that way.
And, I mean, really you can think about it in terms of distance, right? Absolute value is distance. So if you ask, if you want the distance to be less than 4 for x, right? It's anything within distance 4 of the origin, right? And so you can say that's between two goalposts, right? It's between minus 4 and 4. In contrast, when you say, oh, okay, I want points which are further than distance 4 away from the origin, you got to break into two cases, right? It's either the points that are way off to the right or the points that are way off to the left, like x less than minus 4, x greater than 4. And the same is true for more complicated expressions, right? Like, it's the same logic, whether it's, absolute value of x or if it's absolute value of 3x plus 17. But that's the reason I asked problem 8 and problem 9. They're not the same question. And it's easy enough to miss this, right? I mean, like, I'm sure, I think there are people in here who had everything else, pretty well pinned down and just missed this one, It's easy enough to miss this, and you can fix it now that you know about it, right? Oh, you can hit the lights again. Thank you. Problem 10. Oh, the humanity. I mean, the graph-manity. I don't know. If graphs were a people, you've done great harm to the graph people. There's so much wrongness. Not just your section, but the other section as well. Obviously, I have not spent enough class time on this. I'm sorry about that. That's part of the reason I didn't feel bad about adding 12 points to your test. I feel like it's a lot of the reason that you missed some of the points you did was you didn't quite understand this kind of problem. All right? So let's talk through it. Let me make it bigger. So how do we figure out domain from a graph? Nope, that's range. The up and down, highest point, lowest point is range. So the range is the y values that are attained. The domain are the x values which are actually part of the graph. Okay? So here, x values, we have an x value in the graph, not 8, right? Minus 8's got a circle. So minus 8 is not in the domain. That's why I start with an open bracket at minus 8. And then, let's see here. We got a value, we got a value, we got a value, we got a value, all the way over here to minus 2. Minus 2 is defined to be f of minus 2 is equal to minus 6, because of that down there. And then we jump back up here to that open circle at minus 2. I mean, I'm sorry, maybe I should make a solid dot down here to be more clear. If that was confusing on the test, just come ask me. Except I guess I wasn't here. Sorry. Don't worry, I'm only selling my house once this semester, so we should be okay. I'm trying to buy another one, but hopefully I won't do that in class time. So anyway, okay, so x defined, inputs all the way over here to 2, and then notice that between 2 and 4, there's no graph. So that means that the domain should not include 2 to 4. So that's why I go minus 8 to 2 included, and then I jump over to 4, and then we have inputs from 4 all the way over to 8, and that's the end of the story for our graph. Now, if your graph had like an arrow at the end of it, or if it just appeared to go on and on, then you could have like to infinity or to minus infinity in the other direction for other graphs, right? Like, if you talk about the domain for a polynomial, it's minus infinity to infinity, right? The domain for a line is the whole real numbers, There's lots of functions that have domains which are the whole real number system, okay? But this one, it's just that. Now, you're saying the up and down. So for range, we're looking for the y values which are attained by the function. So once we draw the graph, we can see the range by just looking at horizontal lines and asking ourselves the question, like, what's the lowest horizontal line that intersects the graph? Right? What's the lowest value it goes to? In this case, right there at minus 6. So we start at minus 6. It's attained right there at that point, and then it kind of goes up. And think about it, right? We hit the graph. Look here, we hit the graph 1, 2, 3 times. We attain that y value, right? Here we attain that y, again 3 times. Once I'm up here, I hit it once there. I hit that y value, which is about 3. I hit 3 here and here. Definitely 3 is in the range, right? I don't hit 6 here, but I do hit it over there. So 6 is in the range. And so basically the range goes from minus 6 included all the way up to 8 included. because every single y value between those appears on the graph somewhere. And that's how you do range. Once you have the graph, you should be able to see the range from it if you look. Now, if I had somehow, deleted parts of these graphs, I could, you can imagine a picture where you're missing some y values. So you needed to take like the union of two sets to get all the y values, but I don't need to make it so complicated. I have confused more than enough students already with this question, right? So why make it more difficult, right? Hey, f of 0 is minus 2. Can you guys tell me how I know that? How do I know f of 0 is minus 2? What's telling me that? It's this point right here, right? F of 0 is the y-intercept. So f of 0 is minus 2. It's crossing about right there. So output minus 2 for input 0. And f of 3 does not exist because 3 is right here, right? And as you can see, there's no value for the function at 3. So you could say does not exist, or you could say not available, right? 3 is not in the domain of the function. Problem 11, I was surprised how many people got problem 11 wrong. This is definitely something you need to fix if you got wrong. Everyone can certainly fix this. It's not that difficult, I think. Most people had the points plotted correctly, right? Like this is minus 6 is the x, 4 is the y, right? And then 6 minus 2 is down there. I had some people flip the meaning of x and y coordinates and instead plot for me 4 minus 6 and minus 2, 6. That's a mistake I can respect. Like when you make a mistake which indicates a consistent misunderstanding, I like that. I mean, you need to fix it, but a lot of people ignored this minus 2 and put the point up here instead. That's just, I think that's just a careless mistake. The slope, when you work out change in y over change in x, you get minus a half. And since the point 6 minus 2 is on the graph, I can use point slope, and it gives me that formula. There it is. If you simplify that, you get y is equal to 1 minus 1/2 x. And to graph the line, well, once you've plotted these 2 points, just take a piece of paper, rule, or whatever, and connect the dots. That's all there is to it, right? I mean, two points can determine a line. So I think if this problem reappears on the final part 1, everyone should get it right. There is no excuse for anyone to get this problem wrong on the final, right? We can all do this one. I'm quite confident. I think the only way to get that problem wrong is really just to kind of make a careless mistake, right? You do get a formula sheet, right? So you can write down the formulas for the slope and the point slope and all these things. All right, well, anyway, that's all I got to say about that. Oh, and of course, the last problem was the bonus question. Is below the graph of a function, and it's kind of like a national election between a Democrat and a Republican. The vote's going to go about 50-50 once the dust settles, probably these days, and then we're going to fight about it. But so that's kind of how this question went. I think about 50% of you said yes, about 50% of you said no. But in this case, there's a clear right answer, which is no, this is not a function. It fails the vertical line test. If you draw a vertical line test through this, you hit 2 different y values for a given x value, not a function. However, if you look at x squared equals to 4, that actually gives us x is equal to plus or minus 2. X equals to plus or minus 2 gives you these 4 points on the circle. So, all 4 points for which x squared equals to 4, there's these four points here. And I think some of you got some of these points. I don't know if anybody got all of the points. You did?
No, I didn't.
Ah.
I don't know how.
You forgot why you put the points that you did?
No, I got it right.
Did you get all 4 points on your solution? And did you write it was a function? Or did you say yes a function or not a function? You said not a function.
I didn't get the point part. I didn't get the bottom part. The bottom two.
Oh, you didn't get these two, but you got those two?
Yeah.
Oh, that's good. So, yeah. I always try to ask at least one question on the test which is genuinely new and involves some kind of like thinking that I've already shared with you, but maybe used in a novel way. I mean, it's always a goal of mine to have one question on the test like that. I may or may not succeed in a given class to do that, but this is my best attempt in here for that. Okay, I'm going to turn this off, and so I should post this in your in Blackboard later, especially for those of you who are not here. You can look at it there. I'll let you guys choose. Do you want to do more systems of equations at the moment, or do you want to talk more about polynomials? So votes for systems of equations. What's that? I've given you the, did I give you the sheet on polynomials yet?
We did that.
I know I gave you the equation.
We just did like, we didn't do any on this one.
So we haven't done any on the exercise for polynomial functions in algebra sheet, right?
We did 3, 4 for this one.
Okay. So we can go either way. You guys talk amongst yourselves, decide which one you want to do. I had to get my eraser shirt, you know. Let's see here. We should get inequalities and take them out of this class. It would make it easier, you know. Your estimation of my eyesight.
Oh, we picked the one that looks like it has a whole bunch of stuff on it.
They both do.
This one got a whole lot more than the other one.
Oh, okay. Yeah, fair enough.
This one has 28, the other one has 15.
All right, so you have opted for the polynomial path. I like it. So let me just kind of survey the kinds of problems we're going to solve here, right? We have evaluate a polynomial function, that's the number 1. We're supposed to add. Some of these we're supposed to multiply and simplify. And then if you look ahead, exercise 6 to, 21, I think they're all factoring, right? So let's start with the multiply and simplify. I guess we can start with exercise 1, actually. This one's kind of an oddball. So we'll start at the beginning. I'm just going to do this one for you because, tell you what, I'll start it and give you a sec. Oh. Chapter 4, I think it's 4.1. I mean, polynomials are chapter 4, so we're working our way through like section 4.1, 4.2, all your chapter 4 sections, I believe. It's a good question. I wish I foolishly lent my book to a student, and now I have no book. And you'll forgive me, but I'm too lazy to open up the ebook at the moment. But I'm pretty sure it's chapter 4. It is? Okay, good. So here's a polynomial. P of x is 2x squared minus 3x plus 2. what can you, I mean, this is actually an example of a polynomial function. What's a polynomial function? It's a function whose formula is given by a polynomial. You're like, it doesn't seem like you really said anything right there. Well, I mean, fine if you want to look at it that way, but that is what a polynomial function is. It means that the formula for the function is, it's like numbers times x's raised to powers added together, pretty much. Now, here, I'll do something. I'll calculate p of 3. What would p of 3 mean? What do we mean by that? P of 3, we do 2, plug in 3 for every x, right? And we do the operation, and then we should simplify it. And that, indeed, that's all there is to it. So if I plug in 3, I get 2 times 9 minus 9 plus 2, also known as 11. Now, what's the question ask you? Exercise 1.
What is P of 4?
So can you guys tell me what's P of, I'll let you guys work it out. What's P of 4? What's P of minus 2? And what's P of 0 equal to? Fill in these blanks here. So you said, what did you say for 4? 22. Anybody agree with him?
Yep.
So we got a 22. Great. I'm going to do the P of 0. That's 2. Haha. 0 is always easy. Why is 0 easy? The value of a polynomial evaluated at 0 is just the constant term. What's the constant term in the polynomial? Yeah, in this one it's 2, right? But generally speaking, it's just like whatever's left over at the end that's got no x multiplying it, right? What was P of minus 2? 4. Do we have any agreement? All right. So it must be correct. We always judge the truth or truth value of mathematical statements by consensus, right? So if 2 people agree, it must be true. No, it doesn't work in math. It does. But odds are against you both having the same wrong answer. That is true. Okay, so I'll tell you what. Why don't you guys go ahead and try to do exercises 2, 3, 4, and 5. All right. So work on exercises. Okay. I'm going to let you guys work on those. I'm going to work on writing them up here on the board, and we'll talk about them in about 3 minutes or so. By the way, one thing I'm annoyed with your textbook is there is a lack of problems that use the letter X. And yet almost certainly all of my test questions, almost without exception, will use the letter X for the variable. But I tell you what, they have everything except for X. in most of these problems. It's driving me nuts. I mean, it's not wrong, but it's not helpful either. Oh, X. Hooray! So it's important we start with this. And I'm not sure this is enough, but it's a good start because like the next past this thing we're going to do is factoring, right? And what is factoring? It's you could also call factoring unmultiplying. It's sort of unmultiplying, right? So we need to understand multiplying well to be successful at factoring. Because every factoring problem should always be accompanied by a quick check of the answer. And to check the answer for factoring, we multiply. So that's why we're multiplying to start with here. Actually, before even that, we're adding. So I'll give you 30 seconds, then I'm going to start talking about answers. Fruit fly? Yeah. That'll happen. The instructions in each case are to like do the operation and simplify, right? So. Okay, so 30 seconds have passed. So exercise 2, the way I will do this, first of all, is to admit poor planning on my part. I have not left myself enough room to write the answer in the font size I've selected, right? So my first move is going to be to do this. Whee! Equals. All right, so. And so what I'm going to do is just collect like terms, right? So 3b squared plus 5b squared is how many b squareds? 3 plus 5 is 8. So I have 8b squared. And then I'm going to collect together the g squared terms. I've got 2 of those, right? So what's next here? 10 minus 6 is 4 plus 4g squared. And then finally, plus 3, right? So if I put this on the next test and you guys don't get this right, I kill you. No. No. There was a professor at NC State where I went to school, undergraduate, who's well known for telling the students after he showed them the fundamental theorem of calculus, he would say, if I come up to you in the hall and I say, what's the fundamental theorem of calculus, and you don't know, I'll kill you. He's famous for this saying. He also was a pioneer of selfies, if I recall correctly. He took his picture, like his faculty photo, with his camera by himself like this, long before it was fashionable. So, a real pioneer. I tell you his name, but I'm afraid I'm combining stories from 2 different professors. When you get older, you'll do this. So how about this one? We multiply, what do we get?
B squared minus 9b plus 11b minus negative 99.
Very good. Right, and we have to do that because we're supposed to simplify, right? So b squared plus 2b minus 99. And there you go. Now, I'm going to write out. Now, if you're comfortable with what we just did, fine, great, more power to you. If you're not yet comfortable with what we did, there is a way to break up your work and understand it in terms of distributive property. So like this one, we could think about this as 4x times x plus 2 plus 5 times x plus 2. Understanding that that's the substructure of multiplying becomes important when you come to a multiplication problem that you haven't done before, because then you have a way to break it into pieces if you think this way. And then we distribute again, right? What is that? That's 4x squared plus 8x plus 5x plus 10. Now, some of you might have just gone straight to what I just wrote, and that would be fine. I wouldn't take off points. I think you can see that in your head just fine, right? But understand that that's because of the distributive property applied twice. And then we can put our answer in standard format. What do we got? We got 4x squared plus 13x plus 10, right? Answer. We multiplied, we simplified. That's that. All right? How about this one?
You just multiply the first two together.
Why don't you multiply the last two together first? That's too complicated.
You want to do the first two because they're opposite.
Because they're opposite.
And you can just multiply the first two and then the last two.
So you're going to multiply these two first. All right, I like it. So what does that give you?
C squared plus 4x minus 4x.
So you're like, and
Don't even write the middle two because if it's like plus and minus the same number, they're going to cancel no matter what.
now you're right. What you're pointing out is that there's a special form here, right? It's the difference of squares.
Yeah.
And you're absolutely right. We'll talk more about that here in just a second. Now is as good a time as any to talk about it. But you're right, those cancel. And so we've got c squared minus 16 times c squared plus 16, right? So we do like c squared times c squared plus 16 minus 16 times c squared plus 16. And what does that give us? C to the fourth, right? Because c squared times c squared is c to the power 4. C to the fourth. 16 times 16, which is very good. Oh yeah, thank you for the minus. And oh, look, those cancel, right? And so that's cute. So c to the fourth minus 256 is, that's that. Now, what Brianna was just talking about is an important pattern to be aware of, right? So we're thinking about multiplying, and we're soon talking about factoring, right? What is one of the important special patterns? And this is one of them, right? Generally speaking, if you got like something like a squared minus b squared, we should recognize that that's a minus b times a plus b, right? And we can go either right-hand side to left-hand side or left-hand side to right-hand side. Now, you were just applying it, Brianna. You were applying it like thinking of this being c, right? And this being 4. So this is c, and that's 4. So it's like c plus 4 times, c minus 4 times c plus 4. And, well, okay, so fine. We actually, wasn't even that pattern, was it? It was this. You know, you can multiply one then the other, or the other than the multiplication commutes, right? We can do a plus b times a minus b, or a minus b times a plus b. Same song and dance. So that's one of the special formulas that we should know about, yeah, for sure.
I'm just lazy, so I just don't do it.
And this is usually referred to as difference of squares. Or sometimes people will say it's the difference of perfect squares, but whatever. We can leave perfection out of it in here. All right, so this brings us to our next major topic in here, which is probably, you know, if you had to pick like, what are the 3 most important skills you should learn in here, this would definitely be one of them. Like factoring polynomials is huge if you're going to go on in math. And so, you know, we should start working on some and trying to understand how we do it. There really isn't necessarily an algorithm. It's something we just kind of do. And I mean, fine, if the numbers are sufficiently pretty and from the right places, there is a clear-cut algorithm. But in practice, as you actually confront problems, you just try something and see if it works. That's actually how, at least it's how I factor. I don't know. Other people may be more methodical, but so to factor a polynomial, what's that mean?
You should, like,
Take something out, right? If we have f of x, what does it mean to factor it? It means that we can write f of x is equal to like g of x times h of x, right? Where these are both polynomials. So if we can take a given polynomial and write it as the product of 2 smaller polynomials, that's called factoring. And this could be simpler, like the simplest kind of factoring is just pulling a number out of a polynomial, right? So like the most basic example, we've probably already done it, something like this. 3x squared plus 3x plus 9. See, I can factor 3 out, right? There's an example of factoring. I factored the 3 out. It's kind of a silly case, right? But how do I know that that's right?
because if you multiply,
Exactly. If we multiply it out, we get back where we started. And that's the ultimate judge of any factoring example. Another easy example. So let me just hit you with about 10 easy examples of factoring, and then I'll cut you loose on some of the exercise problems. What's that? The ones I'm doing right now? No, I'm making up some of my own. Yeah. We'll get back to the ones on the page in a second, but all mine will be X's. My examples will only have X. So, yeah, but no, these are my examples. So suppose we had f of x equal to x squared plus x to the 4th. Could we factor that?
yes.
Take out a 2, right? Because what you're saying is that this is really x squared times x squared, right? So the basic algebra pattern we're using here, guys, is that if we have a, b plus ac, we can rewrite that as a times b plus c. So that's the key property I'm using, right? This distributive property. But I have to have the a on both terms, right? Like, so in this case, the a is like x squared, right? So if you use your imagination, you can see that the first is x squared times 1, right? So we can factor out x squared, and we're left with 1 plus x squared. That's an example of factoring. All right? Another example. Suppose we had f of x equals to x cubed plus 3x squared plus 2x. Can you see something we can factor out? Factor out one of the x's, right? So you say pull an x out front, right? And then can you guys tell me what I should put in the parentheses here?
X squared plus 3x plus 2.
Right. Now, this problem, I mean, that is an example of factoring, right? But we also use this expression completely factored. So this is partially factored. And the reason I say partially factored over the real numbers is because I can still break down this thing in the parentheses further. All right? So let me show you how I think about this. And you can decide whether or not you like my way of doing it. But what I do is I draw myself kind of a blank template. And I put an x here, and I put an x there because x times x gives me x squared, right? And then I think about the constant term, which in this case is 2. And I think about how can I multiply numbers to get 2?
X plus 1 and x plus 2.
I heard add 1 and add 2. Now, so whatever I put here, this times that, has to be that number. I mean, it kind of seems like there's only one choice here because the only way we think about 2 is 2 times 1, right? But you could think about 2 as like 1/2 times 4, right? You could use fractions. I'll try to stick to whole numbers here for a while. If we're just using whole numbers, that's kind of our only choice, except for what? We could do -1 times -2, but that wouldn't work because then we get like minus for the in-between terms. But this is in fact correct. How do I judge whether this is correct or not?
Factor it back out and get the thing above it.
Exactly. Multiply this back out, we get back to there. And then this is what's called completely factored. You cannot factor it further. Like there's no way to break down linear. These are all linear factors. I call them linear factors because they're like a line. This is completely factored. That's it. Can't do further. Now you might wonder, how about the previous example? Is that completely factored? That's a question. Is there a way to multiply? Can we break down x squared plus 1 into a product of something and something, right?
It have to be a, well, it don't have to be a perfect line. It could be 1 because 1 times 1 is 1. So, yeah.
1 times 1 is 1, yeah.
Plus 1.
Let's see here. How about if we look at this as x squared minus I squared, where I squared is equal to -1. Have you guys ever heard of this before? Complex numbers. So complex number, the imaginary unit is the number such that it squares to -1. People also write I is equal to the square root of -1, you know? But if we did that, then we could go back to your special pattern. This would be the difference of squares. So we'd know that it's x minus I times x plus I. Like that. To my knowledge, this is not tested